where a lot of students found an awful lot of difficulty. I think the biggest problem is that students kind of tried different methods that didn't all quite work. I'm going to start off with a sketch. So I'm just going to draw in my axes and I'm going to say, right, well, my circle, 5 minus 3. So 5 along, 3 down. Somewhere here is the centre of my circle. And then point A, minus 2, 1, somewhere up here. So I've got some sort of circle and I'm just going to sort of try and draw it roughly around like that. So that's something like my circle. It doesn't look great, does it? But it gives me an idea of what I'm working towards and will really help me think about my radius. Because a lot of students were able to say, right, well, for 5A, I know the centre of my circle, so I know that it is an x minus 5 all squared plus y minus 3 or plus 3 all squared in there. Now, absolutely fine. And then it equals r, or in this case, k. Now, instead of so lots of students do different things. They try to subtract 25 and subtract 9 from here and bring those over. Or other combinations of this. What we had to realise is that we've got enough information to find a radius. So we're looking for what the radius is here. So we've got our 2 points, C to A, and we're looking for that length. So the length of a point, Pythagoras' theorem is needed. So let's go for the difference between the x values. So let's do 5 minus 2 all squared. And then the difference between the y values, so minus 3 minus 1 all squared. So that gives me square root of 7 squared plus, that's going to be minus 4 squared. So I've got 49 plus 16 in there, which is root 65. So the radius is actually going to be 65. Since the general form is a minus x squared plus y minus b squared equals k squared, so we're going to obviously have to square what we get for the radius. So that's our general form for our circle, and that gives us 3 marks, and we've now found our radius. Given that AB is the diameter of the circle, find the coordinates of B. So to find these coordinates of B, I'm just going to extend my diagram. It's not the best diagram you've ever seen, but we'll just put B on here as well. So we know that C is the midpoint between A and B, and that's what we're going to use to sort of work this out. So if we think what's happening in the x direction, well, to get from here to here, we were at minus 2 and we've gone all the way on to 5. So that's 7 in the x direction. So we're going to have another 7 to get to the point B here. So add on 7 more from C, we get the x coordinate to be 12. And then if we think similarly in the y direction, so to get down from A to C, we've gone from 1 down to minus 3, so 4. So then we need to go down another 4 to get down to point B. So another 4 down from what is already minus 3, another 4 down is minus 7. And that would then be the coordinates of B. Now, you could do this by using the midpoint formula more formally and rearranging it, or there's probably other ways as well. But I would think that if you've got a nice diagram here and you've realised that to be the middle of the circle must be halfway between 2 lots of radius, then that would work quite nicely. For part C then, I'm going to have to zoom out a little bit or find a little more room. Find the equation of the tangent to the circle at point A, giving your answer in the form px plus qy plus r equals 0. So adding to my diagram then, let's just draw it in a different colour. We have got this tangent, so this point that's just touching the circle just once. So what we need to know for this tangent is, well, actually we know the 2 points. So thinking about our y minus y1 equals mx minus x1 formula, which is our general formula for the equation of a straight line, we know y1 and x1, they're the points given in the question. So what we need is m, the gradient of the tangent. Now we can find the gradient of the radius, which is perpendicular to the tangent at this point here. And apologies for the slightly poor diagram. So we want the gradient of the line AC. So the gradient, change in y divided by change in x. So let's go A to C. So 1 minus minus 3 divided by the change in x. So starting at A, minus 2 minus 5. So that gives me 4 on the top and minus 7 on the bottom. So that's my gradient of AC. Then I want the gradient of the tangent. So that is the negative reciprocal of this number. So that is going to be 7/4. So the minus is forgotten about, if you like, and the fraction is flipped over. So now we've got the gradient here, and we've got the point that this passes through, not point C, point A. That's what it passes through, minus 2, 1. So let's give ourselves a bit more room here. We are going to try and get this, substitute everything in and just sort it out into the format the question asked. So y minus 1 equals 7/4 x minus minus 2 plus 2. And then from here, we're trying to get it into this format. So let's scroll back up again. Everything's on the left-hand side and it equals 0. So multiply through by the 4, 4y minus 4 equals 7x plus x plus 2, like that. Then we'll expand the bracket. So I've got 4y minus 4 equals 7x plus 14. And then everything needs to come over. So it's 4y minus 7x minus 4 minus 14 equals 0, or 4y minus 7x minus 18 equals 0. And we needed it in that form to be given all 5 marks in this question. Okay, for part D, I'm actually going to redraw the diagram just slightly because it's just got a little bit messy. So here is the part of the circle. Actually, that's part of the circle we're looking for. I've got my tangent here, I've got my point A here, and I've got my point C somewhere in the centre of the circle. So what am I being told? I'm being told the point T lies on the tangent. So somewhere on the tangent, there is this point T. And that has a length such that A to T, so this length here, is 4 units. Now, we've already got our radius here, and we know that that has actually got a length of root 65, sorry. So root 65 is our radius. We've got 4 there, and we're looking to calculate CT. So CT, this one here. And there, I'll pop our right angle in there just to show what we're doing. So we're going to be using Pythagoras' theorem here. So 4 squared plus root 65 squared square rooted gives us the longest side. And remember, that's always opposite the right angle. So that's one way to try and look at that. Now, if we then work this one out, I've got 16 plus 65, which nice and convenient comes to something that I can square root. So that comes to 81. So the square root of 81, which is 9, giving me the length of CT to be 9. And I think this question really does illustrate the power of a well-drawn diagram.